Good morning, everyone. This morning, good morning, Ellen. Today we're going to talk about more factoring. Okay, so we have so far, let's recap what we have done. Let's recap what we have done. We have factored. We have solved the equations. One is a if statement and the other, well, one is a statement, the other one is if statement. So we have done these factorings, of various form. Okay, factor, right? In general, we have factored ax squared plus bx plus c. Okay, where a is not 0. And we have also factored by group. By grouping, right? By GCF, greatest common factor. And we have solved equations, in particular quadratic equations, by factoring, right? By quadratic formula, or by completing a square. We wouldn't say we've done completing square for something else. Okay, for something else. So we have that technique. So we will address that way of solving quadratic equations later, if needed. But with these two methods, it's pretty much sufficient. It's pretty much sufficient. Okay, so factoring, and this of course include x squared plus bx plus c as its special cases. Okay, so we have solved the quadratic equations using principle number 5. And today we're going to talk about, oh, by the way, the other thing is factor by special formula, right? Special formula, even though special formula, okay, special formula, of course, can be factored by setting up the, the board or plane of a game. And we can also use this as if we have a squared plus or minus 2ab plus b squared equals to a plus or minus capital B squared. And the other special formula, of course, is a squared minus b squared, difference of squares, equals to a plus b times a minus b. So we have done all of these. And today we're going to talk about the factorings of a to the power 3 plus b to the power 3. And the other form, of course, is a to the power 3 to minus, okay, minus. So do we have a formula for them? The answer is yes, we do. Okay, how does the formula work? How does the formula work? Okay, this is how the formula goes. Okay, if it's a cubed plus b cubed, okay, it's going to equals to a plus b multiply a squared minus ab plus b squared. And the other one, there's a change. It will be minus, and that will be plus. Okay, I know it's a little hard to remember this formula, right? It's hard to remember this formula. And in time, well, if you practice more, you're gonna memorize. The other way is that the only part is kind of, it could be a little, if you rely on your memory, And I never really like to rely on my memory, but I know the general pattern. Okay, I know that if this is a plus, this is a plus, and here's a minus. Everything else will be the same. Everything else, that these two are the same. So if I combine these two, okay, if I combine these two formula, so let's see if that will help us to see better, okay? If it's a plus or minus, and I will be having this situation, okay? And this is going to be plus or minus, but this is going to be minus or plus. Okay, so you see if I can, yes. So if that will help us to memorize. Now, when I'm not sure, I will check. If I have any doubt about if I may have the right formula or not. So now I would like you guys to get your paper pencil, okay, to foil these. Okay, of course, this is a more, you know, it's a little bit more than foil, but you know it's similar to foil, right? So please foil these. Okay, I'm gonna take the lead on this one, and you guys gonna work with me, and then you're gonna do the other one. Okay. So when I'm not certain about certain sign, I would just grab my scratch paper and check it on the side. Okay, I'll check it on the side. Okay, for example, here, I'll take a, multiply a to the power 2. So that's going to give me a to the power 3. And I'll take the a, multiply negative ab. So I get a negative a squared times b. And a multiply b squared, positive b squared. So plus a times b squared. The next one, I will take the positive b, multiply a squared. Okay, positive b times a squared. So that's going to be positive a squared b. Okay, I line them up. You see, I line them up. A squared b, right? Positive b times a squared is plus a squared times b. And positive b times minus ab, negative ab. So that's going to give me minus ab squared. And b times b squared, positive. So we get a plus b to the power 3. Okay, and we obviously see these opposites. And these opposites will make 0. So in the end, I'll get a to the power 3 plus b to the power 3. Okay, so this is verified. So what's being verified? A to the power 3 plus b to the power 3 can be factored into this. After you played with this a couple of times, you kind of have an impression, you have something in at your subconscious level. When you need it, all you have to do is be able to recognize this is a to the power 3 plus b to the power 3, or this is a to the power 3 minus b to the power 3. And you know the basic terms there, and then you can just check it and to verify your answer. Okay, that's how it works for me. So next, I want you guys to verify the other one. 2 minutes. Would that be enough? And then we're gonna learn how to apply these formulas. Got it? Very fine. We'll take your time. Did you verify that? Did? Okay, so let's do this again. Similar, a times a to the power 2, then we get a to the power 3. A times plus ab, we get plus a squared b. A times b squared, we get ab squared. Next, we're going to take the negative b, multiply a squared. Negative b plus a squared. So that's going to give us negative a squared b. And negative b multiply a times b. So that's going to be minus ab squared. Negative b multiply b squared, that's going to be minus b to the power 3. Okay, so opposites cancel each other. So we, in the end, we get a to the power 3 minus b to the power 3. Okay, so verified one more time, right? A raised to the power 3 minus b raised to the power 3 is equals to a minus b times a squared plus ab plus b squared. So if you kind of can tell, this is the formula I just typically, bring it along with us. And in times of not uncertainty, and you can just go check. And of course, in the future, I will show you another way to do it. Okay, I will show you another way to do it. but that will come a little bit later. So today, let's see how we make use of this. Okay, so let's look at alpha 50. Okay, so let's look at alpha 50. Alpha 50. Alpha 50 is we're factoring using real numbers. Factor using real numbers. What does this mean? What does this mean? Right? So I'm going to show you with one example. The first one, x raised to the power of 3 plus 8. That's the first one. Okay. Apparently, this can be written as x raised to the power of 3 plus 2 to the power of 3. So we could use this formula. We can use one of these, right? We could use one of these formula. So the formula that apply to our situation, right? The formula that could apply to our situation, it would be the plus here. If this is a plus, and that's minus. Oh, sorry, this is a plus. This is a minus. Okay, so we can apply that formula. Okay, A is x, B is 2. So that's gonna, we'll plug in the formula, we're gonna get x plus 2. And inside the parentheses, we're gonna have a squared, which is x squared. Okay, minus AB. A is x, B is 2. So minus AB is minus 2x. Plus B squared. B is 2. 2 squared is 4. See, we factored this polynomial of power 3 to power 1 and the power 2. Okay, power 1 and power 2. Of course, the latter factor is a quadratic. The question is, can we factor this further? Can we factor this further? Right, from what we discussed yesterday, that this quadratic, if can be factored, okay? Recall, okay, quadratic, if, quadratic form are like these, right? Where A is not 0, where A is not 0. There are three cases, right? If the discriminant B squared minus 4AC is positive, we can factor into 2 real factors, okay? In this case, that can be factored, right, into 2 real factors, x sub 1. Remember what we did yesterday? X minus x sub 2. Real number factors. 2 real number factors. Okay, and what if this is not equals to, not positive? Then if it's not a positive, there's a case that it could be negative, right? It will be 2 complex number factors. And the last case, and what if it's a 0? Okay, is 2 identical real number factors, i.e. you're going to have something like x minus x1 to the power 2, something like that. So these are the only 3 cases. Let's see what is the case we have here. Okay, let's see what do we have here. Okay, what we have here is that for this quadratic function, right, we have a equals to 1, b equals to -2, c equals to 4. So what is that discriminant? The discriminant will be b squared, -2 squared, minus 4 times a is 1, and c is 4. This is going to be 4. 4 minus 16 is negative. If it's negative, we're going to get, we'll have what? This guy will have 2 complex number factors. Okay? Is factored. Okay. Has 2 complex number factors. But we don't want. We do not want complex number factors. We only want real numbers, right? We don't want to see complex numbers. So at this point, you go no further. We go no further. Do you follow me? We're done. Finished. Okay, finished. So because if you go one more step, you get to complex numbers. So this is, so the factoring is done. So then you can tell the reader, you know what, right? This guy is just equals to that's it. It's done. Okay, so the x to the power 3 plus 8 has only 2 real factors. One is linear and the other one is quadratic. Okay, this quadratic is also called quadratic irreducible. Okay, so this is also called quadratic irreducible. What it means is that it cannot, if you don't, it can, in real number, that's the last factor you can get. If you go one step further, you get to complex numbers. So this is also called quadratic irreducible. Okay, so let me write down the word for you. So this is also called quadratic irreducible. Let me find a symbol for that. Maybe this one. Is there a nicer principle? Symbol. Maybe this one, right? Quadratic irreducible. Quadratic irreducible. Okay, you might see this word in the future that in some different contexts, they really just mean that the complex number will be involved if you want to factor even further. So you have, if you want to stay in real number, you just have that quadratic as the as the final factor. In some situation, I think quadratic irreducible is the most commonly used. Okay, prime, the word prime is often used for if it cannot be factored into integer factors. Okay, integer factors. Okay, all right. So that's the first one on number 50. So next, I want you guys to try to work on number 2. Okay, so could you guys try number 2? We'll see what happens for number 2. Okay, it's x raised to the power 3 minus 8. It's a similar situation. And we want to analyze if this quadratic will be irreducible or not. Okay, we want to see if this is going to be a quadratic irreducible or not. So in other words, if you want to only factor using real numbers, do we get that? So I'm going to give you 2 minutes to work on that. If any one of you want to submit, you can submit multiple. Okay, all of you can submit your work, please. Okay, and all submissions are welcome. Okay, just work on one question and we see to get real number factors what we can get. Okay, so I'm going to turn off the video just for a second so that way you may not feel I'm staring at you. I'm not staring at you, but I do appreciate you work on your algebraic skills. Okay, ready, set, go. What did you get? So obviously we have x raised to the power 3 minus 2 to the power 3 right? And then we have x minus 2 multiply, which formula would apply here? This one, right? So we're going to put that on the side so that we can use it as a reference. Okay. And a squared, a is x, so this is going to be x squared plus ab, so we're going to plus 2x plus 2 squared, that's going to be a 4. Okay. Can this be factored further? You may even try the board of a game to factor it, right? And I assure you, you're not going to make it. It's not going to factor using that integer method. Okay, remember that method? Do you want to give it a try? There. You may want to try this way. No one's going to stop you, right? We're not going to stop you trying to do that. Would you try to do that? I would have told you the answer, but I don't want you to believe my answer. Okay, I don't want you to believe me because I want you to try it. This is where common mistakes are made. Okay, this is where the common mistakes are made. Okay, this is where a common mistake is made, right? If you try to factor, this guy, right? You try to factor, you can use any way you want. You really can use any way you want. Okay. And what do we get here? 1 times 1 is 1. 4 is 2 times 2. -2 times -2. 1 times 4. -1 times -4. All of these, right? So you're gonna make the cross product. This here you get 2. You get 2. The sum is 4. It doesn't match the 2. If you try 1, 4, it's not gonna make it either. Okay. So no matter what we do, it's not gonna make it. Okay. So we cannot find the factors. So this doesn't work. So that's work on this on the scratch paper doesn't work, then you put it away. So what can we do next? If this technique doesn't work and it doesn't fit and if you think about special formula, of course we should think of the special formula, right? And this is a perfect square and this is a perfect square, right? So I'm going to put it as think out loud. Okay, on scratch paper. Okay, so we certainly will try this a squared. I want to show you this because I want to show you that everybody who work on this will make the trial and error. Okay, so b squared. Okay, so b squared. So you may think of this formula, right? And a is x, b is 2. But 2ab is going to be 2 times a, which is x, and b should be what? If this is x, and that is 2, and the middle term will be 2 times x times 2. And we have a 4x here. So it doesn't, we have a 2x here, and here we need a 4x. It doesn't make the match, right? So it doesn't make a match. So it's not a perfect square. So this whole thing is not a perfect square. Okay, so don't take my word for it, especially in these cases, because you don't want to memorize all these things. We have all these tools you can experiment, right? After class, then you start to reflect on what I was saying. Okay, what I was saying. So now, after these methods are exhausted, what do? Quadratic formula, right? It is that tool we were talking about. This tool we were talking about. Very, very useful. Very, very useful. And we've done a lot of examples in quadratic, right? In quadratic. So those are the things you guys, should practice and really know what it means. So now, so in terms of factoring this one, okay, in terms of factoring this one, and continue on this, let me put this on the side. Let me put it over here. Okay. So all of these I'm doing here is on scratch paper. You guys follow me? And I'm going to show you how much work you need to show in the end. Okay, I'm going to show you how much work you need to show. All right. Knowing these information, right? So we're trying to factor this guy, x squared plus 2x plus 4, right? And of course, we know that a is 1, b is 2, c is 4. And then you go straight to b squared minus 4ac. And that's going to give us 2 squared minus 4 times a is 1, and c is 4. So the product is going to be negative. So what does this tell us? And this guy has what? Has 2 complex number factors. And we want real number factors. We want real number factors. So all of these thoughts and work must be considered before you end your work. Before you end your work. Okay, so now with all these said and done, how much work do you need to show? In fact, for this particular question, this is how much work you need to show. This is how much work you need to show. Okay, but you are aware of all of these. Okay, so how much work we need to show for this question? Just 3 lines. That's it. You don't need to show the other things, but you need to know it. We need to know it. Do you guys follow me? You don't need to show everything, really, because your work shows, and where you stop, and it shows that you know what you're doing. Okay, but you need to make those connections. Do you guys follow me? All right. So let's do some more. Let's maybe do 2 more, and then we take a break. Okay, so let's look at the x to the power 3 plus 27. Plus 27. Right there. Number 3. X raised to the power 3 minus plus 27. Okay, plus 27. And what do we get here? What do we get here? It's very similar, right? It's x raised to the power 3 minus 3 plus 3 to the power 3. Right? And then you're going to plug in you're going to use the formula, and that's going to give you x plus 3, right? Okay, if you want to bring that formula with you, right? If you want to bring that formula with you, a is x, b is 3. So this is just going to be x squared 3 times x, and this is going to be 3 squared, and 3 squared is 9. Okay, this step actually, I would say this line is optional. It's optional, but you definitely see it in your mind. You see it in your mind. You can go straight to the next step. So you can just show 2 lines for this question. But you would definitely think about if x raised to the power 2 minus 3x plus 9 can be factored further. Can be factored further in real number. In real numbers, because you have to think about it. In some cases, you can, and so in some cases you cannot. In our case, you cannot. Okay, so I want you guys to check b squared minus 4ac for this guy. So what is b squared minus 4ac here? The discriminant, which is b squared minus 4ac, what do we get? What do we get? Negative 3 squared minus 4 times a is 1 times c, right? Times 9. And this obviously is less than 0, right? 36, negative 36 plus 9, that's going to be negative. So we don't have any more real number factors. So you can just stop here. You can just stop here. So that's all the work you need to show. Actually, just 2 lines, 2 lines. If the second line is optional, okay? Are you guys with me? Has it been pretty easy so far? Yeah? Okay. One more in this section and then we take a break. Okay, I'm gonna take a break. Let's do the last one. Last one, number 13. Okay, I think you guys can handle the rest of it. So we have 4x raised to the power 4 plus 40x. Wait. Okay, let's see what we get. Okay, so we can factor out the 4x. If we factor out the 4x, what do we have left? We have x raised to the power 3 plus what? Plus 10. Am I right? We can still work it. We can still work it. But I want to change it. I want to change it to make it easier for us. I want to change it to make it easier for us. How about I change it to 32? Would you guys change it to 32? Could you do that for me? I don't think we want to deal with the cubic root. Okay. We can still work it, okay? You just do the cubic root, but I don't think we want to deal with that at this moment, okay? And then we just proceed, okay? So we have 4x, and then we have x plus 2, and then we have x squared minus 2x plus 4. We're done, okay? Of course, you're gonna think about that. We already did. Okay, so that concluded alpha 50. Okay, you're gonna try the other exercises, which I have assigned homework for you. And next, we're gonna start working on alpha 51. We're gonna work on alpha 51. Okay, so far so good? So far so good? So let's take 10 minutes break, okay? So let's take 10 minutes break. I see some chat message. I'm sorry, I forgot to check that. Got it, okay. If you have any questions, please let me know. And we're gonna take 10 minutes break and come back at 11:30. Okay, so come back at 11:30. At 11:30. Okay, and I will take your questions and then. Okay, welcome back. All right, guys. I know it's pretty trying. With everything goes on in the world, and going to school online is not easy. You guys have, has stayed for this long time. We may just as well to get something done, right? Hopefully we can try to keep our academics going without much of interruption. Whatever degree you're gonna get, we can push through these hard times before the school reopen again, so we can go back to the campus. Learning online, it does take a lot of effort. Mainly it's mental that because at times it can be pretty trying, okay, challenging mentally, whether we have the perseverance to keep going. Okay, I'm totally with you. And I hope we can make this semester a productive one and everybody walk away with a decent grade. And I'm here to help. And some people may not make it because they're gonna watch the recording later. But we're here, so let's try to make the best of it. Let's try to make the best of it. We have 5 more weeks to go. I think we have 5 more weeks to go. This is week 11. So after today, week 12, 13, 14, 15, 16. Week 16 is the final exam. We're gonna meet once and then you're gonna do your final exam. So 4 more weeks to go. Let's say 5 weeks. Okay, we have 5 weeks to go. So let's make the best of it. Okay, let's make the best of it. We have seen the end of tunnel. We have seen the end of tunnel. All right, so alpha 51, solve for x. Okay, in this case, solving for x, we were not specifically asked to find real numbers. So any number, right? So let me show you an example. Number 1, we got x to the power 3 plus 8 equals to 0. Of course, this is an if statement, right? This is an if statement. Okay, this is an if statement. With that if statement, we're trying to solve it. Okay, we're trying to solve it. There are a number of ways we can do this. But we should expect 3 solutions. Usually polynomials, if the degree is 1, you have 1 solution. If the degree is 2, we have 2 solutions. Degree is 3, we have 3 solutions. When they ask us to solve for x, the intention is to find all the solutions. So we should have 3 solutions. Okay, we should have 3 solutions. Okay, so how do we find those 3 solutions? So what we do is we factor. So we get x plus 2. We had done similar things before. So we have x squared minus 2x plus 4 equals to 0. So if this is true, then this is true. Okay, so now I'm going to view this letter form as the product of 2 numbers is 0. A times B is 0. Okay, principle number 5 applies, right? So this is A and that is B. So this is A and this is B, right? So this guy is A and that guy is B. And A is x plus 2 and B is the other one. Okay, B is the other one. Okay, so that's the perspective. And then we're gonna say, okay, we're gonna follow this principle number 5. We know that either A is 0 or B is 0. Okay, or both are 0, right? Who knows? But A is 0 or B is 0. So that will lead us to x plus 2 equals 0, or x squared plus minus 2x plus 4 equals to 0. And this piece is easy. We will end up with x equals to 2. Okay, how about the other one? We need to solve this quadratic equation. We need to solve this quadratic equation. We need to solve this quadratic equation. The simplest way to solve this quadratic equation, right? Solve this quadratic equation. Of course, you can try factoring, but we have already tried factoring, right? It's not easily factored. So just go straight to quadratic formula. Just go straight to quadratic formula. And we already have the discriminant, which is b squared minus 4ac, right? Minus 4ac, and b is negative 2. A is 1. C is 4. Okay, so it's a 4 minus 16, negative 12. Okay, so we know we expect to have complex number solutions here. So we just plug in. Okay, so x equals to 2a in the denominator, 2 times 1, and negative of negative 2, plus minus square root of negative 12. Square root of negative 12. Okay, simplify. We will get denominator, we have 2, negative and negative 2 is positive 2, plus minus square root of negative 12, and we will write that as negative 1 multiply square root of 12. Okay, of course, 12 equals to 4 times 3, right? Do you guys see that well? Okay, and then afterwards, okay, so let me put this beneath it. Okay, afterwards, what we get is that this is I, right? And root 4 is a 2. So we take the 4 out. So this is 2i times root 3. And there's a 2 here, there's a 2 here, there's a 2 here. So we can do some reduction. So the way we do the reduction is that we're going to factor the 2 on top. Okay, and then we get a 1 plus minus plus or minus root 3. And the 2 on top will reduce the 2 in the bottom. So in the end, we get a 1 plus or minus root 3. So solutions, right? So what are the solutions we have? We have x equals to negative 2. Hold on, I think I made a mistake. This is negative 2. Sorry about that. And the other solutions are going to be x equals to plus minus 1 plus or minus root 3. So there's Oh, wait, I forgot the I. Sorry about that. I forgot the I. Okay, there should be an I there, right? I, yeah. Okay, so that's the three solutions. Be very careful, okay? I don't recommend to write it this way. I don't recommend to write it this way. Even though this way of writing is correct, but if you just not being very careful and you write this square root sign, it's just a little bit longer, you're committing a mistake. You're committing a mistake. Okay, so you have to be super careful. So the best way to get around it is just put the I in the front. Okay, just put the I in the front. So I don't encourage this way of writing. Don't do this. Don't do this. Okay, just cross it out. Okay, don't do this. Okay, it's not a mistake, but we can easily make a mistake. We can easily make a mistake. Okay, so you can see in this way of writing, you try to be as clear as possible. You try to be as clear as possible. And this is what I follow. You see all the way here. You want to be clear, and you don't want to have, you don't want to, people think that this is 1 plus minus the square root of 3i, and that will be a mistake. This will be a mistake. So you can see easily, right? So don't do that. That's a mistake. That's a mistake because the bar is, the square root of bar is too long. It's too long. Okay. So that's for this question on number one in Alpha 51. Okay. There are only like 4 questions in Alpha 51. I think after one example, do you think you guys can handle it? How about you guys do one more? You guys do number 3. We're gonna do number 3 together, but you guys taking the lead. Okay, you guys taking the lead. So let's do number 3. Ready? Are there any submissions of work? Oh, nobody submitted any work. Why not? Why not? Yeah. Okay. Okay. Please take the lead and do number 3. And number 3 is x to the power 4. Oh, where did I put my x? Okay. Over here, where's my cursor? Okay, x raised to the power 4 plus x equals 0. How's it going? All right, so let's work on this together. And we're gonna solve the equation. Of course, we're gonna find all the solutions. How many solutions do we expect, right? We expect 4 solutions because the degree is 4. Okay, we expect 4 solutions. And so to find those 4 solutions, we're gonna factor. After factoring, we have x raised to the power 3 plus 1, right? And the 1 is the same as 1 to the power 3, so we can use that formula, right? And then we get x times x plus 1 multiply x squared minus AB, right? That's x, and plus 1 equals to 0, right? So we're gonna have 2 solutions from here, and we're gonna have 2 solutions from here. And this obviously will remind us of that perspective, which is A times B. Wait, okay. A times B is, principle number 5 times B times C equals to 0, right? If the product of 3 number equals 0, so then of course we know what to do next, right? It will be A equals 0 or B equals to 0 or C equals to 0, right? So that's the scenario. Okay, so let me maybe make the font just a little bit smaller. Okay, so that way we could have that fitting into that line. All right, so if x is 0, right? Or x plus 1 is 0, or x squared minus x plus 1 is 0, right? These 2 solution equations will give us x equals 0 or x equals to -1. So here is x equals 0 or x equals to -1. So here x is going to be equals to -1, or we have to solve this equation, right? We have to solve this quadratic equation. Solve this quadratic equation. Okay, with that, how do we solve this quadratic equation for x? Right, we certainly would think of factoring by, the game board, right? But you try to make it, and let me assure you, you cannot make it. You're not gonna make it, okay? That technique doesn't make it, okay? But you can try, okay? So on your scratch paper, you think out loud, right? Factor. Quadratic formula always is useful, right? So whatever you try, so try factoring. Not easy. Okay, so eventually we will resort to quadratic formula. So we're going to do the discriminant, which is b squared minus 4ac. And that will give us b is -1 squared. B squared is -1 squared. And a is 1, c is 1. And this will give us a -3. So we expect 2 complex number solutions, okay? So the 2 solutions will be x equals to 2a, 2 times a is 1, right? A is 1. minus of negative 1, that's a b, right? Negative b plus minus the square root of a negative 3, the square root of a negative 3, right? Then we will simplify. 2 times 1 is 2, negative 1 is a positive 1, and here negative 3 in the square root, we're going to write it as negative 1 times 3, right? And you can write it separately as root of negative 1 times the root of 3. Okay, and that expression, okay, we know how I is defined, right? It's a square root of negative 1, right? So this guy is an I. Okay, so we got our 2 other roots. We got 2 other roots. So finally, the solutions will be what? X equals to 0, negative 1, or these 2. 4 solutions. Okay, with that, I would like to conclude. Alpha 50. Okay, and we're heading to alpha 52. Which is solving by completing a square. Okay, so alpha 52. Hopefully this will be relatively easy for you because we've done completing square in a different setting. Okay, and I also want you to be aware of the differences. Okay, recall that we did completing a square before, okay, in the function setting. Okay, for example, what we did here, okay, so we have f of x equals to x squared, that example we did, plus 2x minus 3. Remember that example? What we did is that we're working on the statement. So when we are working on the statement, what we did there is that we add a number, we subtract a number, right? So we add a 1 and we subtract a 1. So we basically added a 0. So the principle we used, there is a principle number 2. Okay, anything add 0 stay the same. Anything add 0 stays the same. i.e., if you take any number, you add 0, it's still going to be the same number. Okay, anything add 0 stay the same. So any number add 0 is still the same as this number. Okay, so that was the principle we used. Okay, now let's look at the first example in number 1. We're still going to make a perfect square, right? We're going to make a perfect square. So minus 1 equals 0. This is an if statement. Okay, this is an if statement. Okay, so it basically says it if, right? If A is B, right? If the left-hand side is the same as the right-hand side. If A is B. So you can see the principle we're going to use are going to be different. Okay, then A A plus C is equals to B plus C. No restriction about C. Okay. So in this method, the principle that we apply is different, even though the numbers we're adding is similar. So what we do here is that we're going to add. Okay, so first we're going to move the -1 to the other side. Okay, so that's going to be +1. So we add 1 on both sides. So we already used this principle, right? We already used this principle. So we use this principle. We already use this principle. Okay, so we can remove that. Okay, and then to make a perfect square, what we do is on this side, we have x squared plus 2x, okay? We're gonna +1 on this side, and the other side, we're also gonna +1. You follow me? And the principle we applied is the same. Okay, it's the same principle. You see, there's a difference between what we did here, which we add a 0, and what we did here, which is on if statement. Okay, so this is on a statement because this is just a description of a rule. This is a rule function. And this one is an if statement, which is, you know, if A is the same as B, then A plus C equals B plus C. So even though there's similarities, okay, so here we add 1, subtract 1, but here we add 1 on both sides at the same time because this is an if statement. So we use the principles for if statement. Do you guys follow me? That's the primary difference. Okay, so when you write it down, you have to write it down properly. Okay, you need to write it down properly. In this case, in the cases we did in quadratic, you have to add a 0 because you don't have another side. You don't have another side in this statement. On the if statement, however, you do have another side, so you can add the same number on both sides. Do you follow me? Okay, I hope that is clear about that principle. And next, of course, we have made the perfect square, that's x plus 1 squared, right? If you factor the left-hand side, and you're gonna get x plus 1 squared, and that's equals to 2. Okay, and that is equals to 2. And then what? And then what? Then you're just gonna take square root on both sides. Okay, we're gonna take square root on both sides. Take square root on both sides. Oops. Square root on both sides, right? And the left-hand side. So in the whole process, we're working on number 1 of 52 is that we're operating under the if statement. If this is true, then that. If this is true, then this is true, right? And if this is true, then this is true. And if this is true, then this is true. So we're working on a if statement context. And the other one is not. This one is not. You just simply make some changes in forms about that statement you're working with. They're still the same statement. The description, the rule of the function doesn't change. For the same input, you still produce the same output. So these are fundamentally different. Now, the next step, we got the absolute value, and that's equals to square root of 2. Okay, and we're solving this absolute value equation, which is x plus 1 equals to plus or minus root of 2. And last but not least, we're going to isolate x. So we're going to use this principle one more time. Okay, we subtract 1 on both sides. So x is equals to -1, okay, plus or minus square root of 2. So we have two solutions. We have two solutions. Do you follow me? Do you follow me? Do you want to try one? I would like you guys to try number 3. Okay, I would like you guys try number 3. Okay, Alan, Francisco, Marcelo, everyone, I want every one of you submit the work for number 3. Okay, so I hope you're not scared. Okay, don't be shy. Okay, solve by completing a square. Solve by completing a square. Okay, know the difference. Know the difference. Okay, so everybody's doing number 3, and I'm asking you guys to submit your work. Okay, x squared minus 4x plus 2 equals to 0. Okay, by completing a square. By completing a square. Okay, so you see the difference. Okay, and you saw how we did number 1. So I'm going to give you 3 minutes. 3 minutes. Would that be okay? Okay, let's do 3 minutes. Anybody have submitted your work? Well, is going to submit your work? Alan, Francisco, Marcelo, please, I would love to see your work, every one of you. But if you want to choose a different question to do, that's not a problem either. Yeah? Don't be shy. Don't be shy. I'm here. Is that a submission of work? I hear something. Nope. Come on. Ellen, Francisco, Marcelo, could you please submit your work? Do you need more time? Chat message. More time. Okay, more time. I give you more time. You got it. You got more time. Okay, I'm gonna give you a little start to see if you're on the same track as mine. I'm gonna add a number on both sides. I'm gonna add some number on both sides. I'm gonna add the same number on both sides. That's okay, Francisco. No problem. Okay. I would just love to see your work. Which could you, when you're ready to submit? Because you're not sure, so it's make it even more valuable for us to look at your work together, right? That's how we can help each other, right? For me, you're helping me to know if my teaching has reached out to you, if you really get it. And for you, you want to know if you haven't learned it. So in both ways, you know, for both of us, for you and me, that it's important for us to, you know, to get to know this, right? Do I really know how to do it? right? And for me, I taught you how to do it. So don't be shy, just take your time, okay? So you have to figure out what number to add on both sides to make that perfect square, okay? More time, you get more time. Francisco, since you did it, would you like to submit? All you have to do is just take a picture and send it to chat. I'm sorry, send it to the Pronto. Or you can send it to the chat, upload the file. And you can continue to try another one. You may find that in this case, the perfect square tables are very useful, right? So what you do is that you're gonna take the 4 and divide it by 2, and 4 divided by the 2 is 2, so that you're gonna add a 2 squared. So you're gonna add a 2 squared on both sides. Okay, which we're adding 2 squares on both sides. And if you factor the left-hand side, are you factoring the left-hand side? You should get x minus 2 times x minus 2. Okay, any technique of factoring you want. And the right-hand side, of course, is a negative 2 plus 4, and that's going to be a 2. Sorry, 2. Okay, and so the left-hand side is really x minus 2 squared. It's a perfect square. Okay, it's a perfect square. And next, we're going to take a square root on both sides. You can still submit, you guys. You can still submit. Okay, feel free to submit so I can check. Trust me, I can still find something to, maybe you have done something differently from mine, right? And you want to double check with me. So take a square root on both sides, and then we get absolute value of x minus 2. And that is equals to the square root of 2. Right? And then solving this absolute value equation, we get x minus 2 equals to positive or negative square root of 2. In the end, we add 2 on both sides. We add 2 on both sides. Okay, if A is the same as B, adding the same number on both sides. So we use that principle a lot. So plus minus 2. So these are the solutions. We get 2 solutions. You can see that? So that's number 3. That's number 3. Okay. Okay, I made a mistake on this third step. So I don't put power to 2. I didn't put power to 2. Oops. See, you self-check is a very powerful learning ability, and you have that ability, right? So you can check for yourself, did it work or did it not work, right? Very good. Shall we try another one? Shall we try another one? So this time I propose, do you guys get it? Did you guys get it? So you may like to, then you realize that perfect square thing we have learned before is pretty useful, right? Absolutely, absolutely. Okay, the perfect square, to make perfect squares. Okay, so this one I propose we try number 7. I propose we try number 7. Okay, so let's try number 7. Ready? Let's go. X squared plus 6x plus 5 equals to 0. I'm going to solve by factoring. Of course, the first step, you're going to subtract 5 on both sides, right? So you're going to have a negative 5 on the other side. On the other side, now we need to figure out what number do I add? What number to add? Okay, what number do I add? Okay, on both sides. 3? You're very close. Remember, you have to make a perfect square. Add a 2. Add a 3, add a 2. If you add a 3 and you factor the left-hand side, does it make a perfect square? If you add a 2, does the left-hand side, if you factor, does it make a perfect square? That's the question we're asking. Okay. And also, you will be thinking about a squared plus or minus 2ab plus b squared. That equals to a plus minus b equals that perfect square, right? You'll be thinking what number I should put here to make a perfect square. 5 is not a perfect square. No, 5 is not a perfect square. Right? So you're gonna have to choose a number to add to, right? Of course, you don't have to do the same way I said. So 1, right? You add 1. Where do you add 1? You add 1 here, doesn't make a perfect square. Because your question is, our question is, if you add a 1 here, you add a 1 here, you factor the left-hand side, doesn't make a perfect square. You don't have to worry about the right-hand side. You just have to worry about the left-hand side. You just make a one side perfect square. We cannot make both sides perfect square most of the time. Okay, but we can make a one side perfect square. Okay, so in this case, what you can do is that you can see that there's a correspondence, right? If you can make something like this, right? If you can make something like this, and then you can see there's a correspondence, right? There's a correspondence. X squared corresponds to X corresponds to A. So A is X, right? 2 is the power. So X squared corresponds to A squared. And there's something here, it has to be you have to have a correspondence here too. And there's a plus, so this is going to be a plus. This is going to be a plus. Right? 2AB, 2AB, you know A is X. So 6 can be written as 2 times X times 3, isn't it? So 2AB. Do you see that? 2 matches A, 2X matches A because X is A, and 3 matches B. Do you guys see that? So what should this number be? You want that number to be B squared, right? From this process, we have decided B is going to be 3. So you will need a 3 squared. Do you follow me? Do you see that? You want to add a 3 squared. Okay. So think out loud. Get a piece of scratch paper. Right? You have this. We have that. Right? And we're going to factor. So where's my boxes? Where's that game board? Where is it? There. Right? So I brought my game board here. Okay. So I'm going to try to see if the factor will work out. Okay. So 1 is equals to 1 times 1, and over here is a 6x, right? It was a 6x. So now I put a plus 3 squared. So I'm going to put 3 times 3 is 9, right? 3 times 3 is 3 squared. So 1 times 3 is a 3, not 4. 1 times 3 is a 3. 3 plus 3 is a 6. Yeah? You guys see that? And 6 matches the 6 perfectly. Okay, so if you match with the formula and you found your A is X, right? So this is going to be X plus 3 squared. If you factor, you also get X plus 3. So here you're going to get X plus 3, and over here you're going to have an X plus 3. Do you follow me? So in the end, your factor form should be x plus 3 squared. And you can verify. You can verify. Okay, you can verify by FOIL that. Okay, you can verify by FOIL that. Okay, so that's going to be x plus 3 times x plus 3. And you FOIL that, you're going to get exactly x squared plus 6x plus 9. Okay. The other thing we notice is that you can see the 3 is a half of 6. 3 is a half of 6. Do you guys see that? 3 is a half of 6. Okay. 3 is half of 6. Half of 6 squared is the b square you're looking for in this situation. Okay, so that was a pattern we have seen before, right? That's a pattern we have seen before. And if you look at the perfect square part, right? The perfect square part, we did it before, right? So after all of these considerations and considerations and comparisons and so on and so forth, so what you get here? You add a 9 on both sides. If you add a 5, it's not going to work. If you add a 6, it's not going to work. You can keep trying. We can keep trying. It's trial and error. Okay, trial and error. So by this time, we have decided the number we're going to add on both sides. Right, so from this formula, you can see A is x, B is 3. And x plus 3 indeed is equals to x squared plus 6x plus 3 squared. And we want that perfect square form. So x plus 3 squared equals to -5 plus 9, that's equals to 4. Does everybody follow now? Yes? If you want to review the perfect square part, right, it should be in the earlier notes, Okay, I think, let me check and I tell you where you can find it. Perfect square. Okay, you should find it at where we covered it. You know, on March 17th. Okay, the lecture is on March 17th in those dates. Okay, March 17th, March 15th, and later dates. And you find it at alpha 18. Okay, alpha 18. Okay, you will find those related topics about perfect square. Okay, about perfect square. Okay, are we good? But we're not done yet, right? We are not done yet. We're not done yet. So can you finish that? Can you redo the whole thing and finish? Okay, so what I'm going to do is I'm going to ask you to do it on your paper. Okay, I'm not going to put away the screen, but I want you to redo the whole thing on paper. Okay, please redo the whole thing on paper. Okay, so whatever mistake you have recognized, don't throw them away. Do not throw them away, please. Okay, those are valuable lessons. Okay, those are valuable lessons. Okay, do it all over again. Okay. I'm going to give you the perfect square table. Okay, review the perfect square tables from alpha 18. Okay, so I'm going to bring back those alpha perfect square tables, 2 columns, many rows. Okay, right? If we have x plus 1 squared, it is, if we FOIL that, you do your work, okay? Just do your work, plus 1. And I'm going to put this one over here. And let's reestablish those tables. A plus b squared equals to a squared plus 2ab plus b squared. Okay, minus, and this is minus, right? So if it's x plus 1 squared, and we will get, if this is minus, it's going to be a 2, right? And you can see 1 is the same as 1 squared. What do we also notice that this 1 is half of 2. This 1 is half of 2. Okay, so let's work on x plus 2 squared equals 2. And I want you guys to FOIL that. You're going to find a pattern that will pleasantly surprise you. Okay, so what do we get here? What do we get here? Right, x is a, b is 1 here. Now x is a, b is 2 here. Okay, so when you FOIL x plus 2 squared, do you know how to FOIL x plus 2, x plus 2? Let's do FOIL x plus 2. Right? So this one is x plus 1 times x plus 1. Just FOIL them. You're going to see very well. Okay, so you're going to get x squared plus 4x plus 2 squared. And x minus 1 squared is x minus 1 times x minus 1. Okay, so let's FOIL these together, guys. Okay, we can do it. We can do it. Right, that's what it takes. Right, over here, you're gonna get x squared minus 4x plus 2 squared. Okay, so I'm not writing 4, I'm writing 2 squared because we want to observe there's a pattern. There's a pattern. Okay, so I want you guys to do all of these. Okay, x plus 3, x minus 3 squared. Let's work it out. Let's work it out. Any submissions, anybody? So this will be x plus 3 times x plus 3. Okay, just FOIL these, okay? It's a lot of fun to work these out. X minus 3 times x minus 3. So what do we end up with? You can see here in the general formula, b is half of 2b, right? B is half of 2B. And 1 is half of 2. 2 is half of 4. 1 is half of 2. 2 is half of B, half of 4. B is half of 2B. Do you see that? Okay. All right. So what do we get here? X squared plus 6x plus 3 squared. So once again, 3 is half of 6. And now this is going to be x squared. Did you get it? Minus 6x plus 3 squared. Okay, so once again, 3 is half of 6. So to get the perfect square, what do we need? We need x squared. We need a 2ab. Okay, minus 2ab here now plus b squared. Okay, and this is the situation we are currently in. Okay, but we're working backward. We're working backward. Okay, so what do we have here? Okay, we have x squared plus 6x. In order to make that perfect square, we need a plus 3 squared. So that's why we plus 3 squared. Once we plus this 3 squared and we factor it out, and we're going to get x plus 3 squared. Got it? Is that clear, everybody? Yeah, Francisco? Okay, so can you work it out and submit the work? Ellen? Or Marcelo? Oh, by the way, quiz number 18 is available. Okay, please try. Please try. We're not finished yet. We're not finished. Okay, so do it from the beginning to this point and then finish. So how's it going? Sure, you can send it on Pronto. Alan, would you like to send it to? Marcelo? Yeah? I'm here. I'm ready. I'm ready to look at your work. Please. Okay, take your time. Got it. Thank you. How about Ellen and Marcelo? Thank you for sharing that. So I'm going to share that with you guys. So what you shared is x plus 4 squared is x plus 4 times x plus 4 is x squared plus 8x plus 4 squared. X minus 4 squared is x minus 4 times x minus 4. Yes, very good job. Very good job. Yes, okay. These are good. These are good. So you can see that you know, this is where it gave us the idea as what to, you know, what to add on both sides. Okay, very good job. Okay, so you can see that there are other cases in you know, alpha to 52 that we can use these ideas, right? Okay, so let's go back to where we were. Okay, so for this particular situation, we're adding 3 squared because we're chosen 6, half of 6 is 3, and we added 3 squared. Got it? And then after we get to this point, we're taking square root on both sides. We're taking square root on both sides. Okay, of course, the square root of 4 is 2. And the next, we will get to the absolute value of x plus 3 equals to 2. And solving this equation, of course, we're getting x plus 3 equals to plus 2 or minus 2. Okay, so we got some pretty nice and neat numbers here. So we can separate them. We can separate them, okay? So x plus 3 equals to -2, or x plus 3 equals to +2. So in the end, we get two solutions, and these solutions are pretty pleasant. X equals to -5, or x equals to -1. You guys see that? So this is the whole of this question, the whole of this question. Okay? Now, I want you guys to try one more. Okay? Francisco just did x plus 4 times x plus 4 squared. So for that, I want you guys to try number 9. So could you try number 9 for me? Number 9, where you already have the x squared plus 8x plus 12 equals to 0, right? You're going to choose a number to add on both sides after you subtract 12 on both sides, right? So you're going to choose a number to add on both sides. So first you subtract a 12, you get a -12. So what do you add over here? Okay, so what do we add on both sides to make that perfect square on one side? With the example number 7 right in front of you, shall we figure out that? And think about x plus 4 we have done, right? X plus 4, which you just did, right? X minus 4, which you just did. Okay. What do you add on both sides? Alan, Marcelo? What number to add? I would appreciate an answer. Please help me. Please help me. What number should be in the place of the question mark? Yes, no? Knowing that, right? Knowing this. So that's x plus 4 times x plus 4, right? And over here, it's x minus 4 times x minus 4. And you FOIL that, you get x squared plus 8x plus 4 squared. And over here, you got x squared minus 8x plus 4 squared. What number shall we add? And what will be the consequence of adding those numbers? Adding 4? Adding 4 will make it? Adding 4? If you add 4, right? We meant that this is going to make a perfect square. We add a 4, and this is going to make that perfect square. And what is that perfect square? X plus what square? Right? So do we add 4? Does everybody agree? Do we add 4? Is it going to make it? You're very close. You're very close. Marcelo agree, adding 4. How about Ellen? Ellen, do you agree with adding 4? Where's Ellen? Ellen, are you there? Do you think adding 4? Oh, Ellen agree with adding 4? If we're adding 4 here, is it going to make the perfect square? So what number should be here for that perfect square? Look what you did here. We have an x squared, we have a plus 8x, and we have a plus 4 or 4 squared. Yeah? So should we add 4 or should we add 4 squared? These are two different numbers. So what number should we add? Is it going to make it? That's right. We should add a 4 squared. Adding a 4 squared in the circle x squared plus 8x plus 4 squared. And if you factor this, you're going to get x plus 4. Then you get an x plus 4 squared. You follow me? So you guys are very close, very close. Okay, so now we finally figure out the number we're adding. Right? Did you get it? Okay, so then what is that perfect square on the left-hand side? It's right here, right? It tells us. So it's x plus 4 squared equals to negative 12 plus 16. That's equals to 4. Right? So then we're going to take square root on both sides. Okay, and that equals to 4. Square root of 4 is 2. Okay, and then in the end, well, close to the end, we have absolute value of x plus 4 that equals to 2. And then we got x plus 4 equals to plus or minus 2. Okay, and then what? It will be x plus 4 equals to negative 2, or x plus 4 equals to positive 2. Okay, so x equals to negative 6 will be one of the answers, and the other one would be x equals to negative 2 for the other answer. So that's our solution. Okay, and I think we're going to continue to do this. And this week, I will give you another quiz about perfect square. Okay, so I want you guys to do x plus 4 squared, and you continue on this table until x plus 5, 6, etc. 7. Okay, and for the other side, okay, for the other side, you're gonna work out all these other tables this weekend. Okay, you have another quiz regarding these. Okay, what number to add to make that perfect square? Okay, and hopefully next week when we come back on 52, and you have tried some questions and have some other questions for me. Okay, and I will see you guys on Monday. You should expect another quiz. Quiz number 18 is available now, and I apologize for the mistake I made. And